Hello there, my name is Ben McGahee with McGahee Mathematics, and this lesson is on linear inequalities. And so linear inequalities, they're similar like in solving a linear equation, except you don't have just an equal sign, not saying two things are equal. You're actually going to be comparing things. You may have maybe dealing with the signs that have, greater than, less than, greater than, equal to, and then you have less than or equal to. So those are the four inequality signs we'll be dealing with when solving linear inequalities. So, for example, let's look at if you have x is greater than 2. Well, you can actually think of a lot of values that are greater than 2, right? There's 3, 4, 2.5, any number greater than 2. There's actually an infinite amount of numbers that are greater than 2. So how can we express this inequality like on a number line? So if we were to draw a number line, let's just say we start in the middle, we have 0, 1, 2, 3, 4, and then so on to the right. And we'll say this always goes out to a big number, say positive infinity, big number. And then we go the negatives, -1, -2, -3, -4, and then so on all the way to very small numbers, very small numbers called negative infinity. So if we want to graph x is greater than 2, all of those numbers, then we start at the number 2, and if it's greater than 2, we see that it's not equal to 2. So what we're going to do is draw an open circle, not coloring 2 since we're not including that number, and then we're going to shade all of the numbers to the right of 2 that are greater. And so that would be the way we graph x is greater than 2. Now, there's another way to express inequalities, and that's through interval notation, where you write either with the parentheses or the brackets. You might have seen those before. And the way we do this is we start at 2, so we write number 2. And since it's, we're not including the value 2, we're going to use a parenthesis. And then we'll do comma. And then we're going all the way to the big number infinity. So we'll do infinity. And since we really don't know what infinity is, it's just a very big number, we'll also include parentheses for that as well. So it'll be 2 comma infinity with parentheses. And this is what's called an open interval, because we don't include the endpoints, the 2 and the infinity. Those are called endpoints. So it's called an open interval. A closed interval is where you have the brackets on both ends. So for example, if you had 1, 3, this would be an example of a closed interval with the brackets. And then if you had a semi-open, it would be like 0, and then maybe you have 1, semi-open, semi-closed, or there would also be maybe -2, 4. These examples right here would be semi-open or semi-closed intervals, because we each have a parenthesis and a bracket for those intervals. Okay, So now let's look at another example. Let's say if I have y is less than or equal to -3. And we'll do exactly the same thing. We'll draw a number line. So we'll have 0 here. We'll do 1, 2, and we'll say 3. And then we have -1, -2, -3. And we notice it's less than or equal to with -3. So we actually, this time, we need to, instead of an open circle at -3, we're going to do a colored circle, because we want to include that value for -3, and everything that's less than -3 is all numbers to the left of it. So we're going to shade all the numbers to the left, and we'll remember to include our negative infinity and positive infinity to the right. So and this time, when we do our interval, we're going to have, we start at negative infinity. We start from the left, and then comma, so parenthesis, and then we go to up to -3. And do we include a bracket or parenthesis? Well, since it's colored in and we actually include the equal to -3, we have a bracket. So we have the semi-open, semi-closed interval, negative infinity, -3. Okay. So the notation takes a little bit to get used to. The graphing's pretty visual. Most people, can understand that okay, but it's sometimes the interval notation takes some time to get used to. Just remember that the smallest number goes first in your interval, and then the largest number where you stop, that's the largest value in the interval. Okay, so let's try to solve a linear inequality. Let's say we have 5x minus 7 is greater than equal to 13. So this is just like solving equation. You have to get x by itself. So we add 7 on both sides. Those will cancel. And then we have 5x is greater than equal to 13 plus 7 is 20. And then we divide both sides by 5. So those cancel. And then we're left with x is greater than or equal to 20 divided by 5 is 4. So x is greater than equal to 4. And we won't actually graph this on the number line, but we'll write an interval notation. So we start at the smallest number. We see that's going to be 4. And we include a bracket because this is equal to. And then we comma everything greater all the way up to infinity, parenthesis. So that would be our interval notation for our solution, x is greater than equal to 4. Okay. Let's try one more. Let's say we have the variables on both sides. 12t plus 4, say is greater than, so just greater than 18t plus 10. Okay, so what we'll do is we'll get the 18t over 12t, so we have to subtract that to both sides. Right, so those 18t's will cancel. And then we're left with 12t minus 18t is negative 6t. Negative 6t plus 4. It's greater than 10. And then we have to subtract the 4 over to both sides. So those will cancel. And then we have negative 6t, kind of at the bottom here, greater than 10 minus 4, that's going to be 6. Now, I'll bring this up top since we're out of space here. So negative 6t greater than 6. So we'll divide by negative 6 to both sides, and cancel. And then we have t. And here's the thing with inequalities is when you divide both sides or multiply both sides by a negative number, you have to reverse the inequality. So this is greater than for right now, so we're going to have to switch it to less than. And 6 divided by negative 6 is negative 1. So t is less than negative 1. So that is one rule you have to remember when doing it in linear inequalities, is when you divide or multiply by negative to both sides, you have to flip the inequality sign. So t is less than negative 1. So our solution is going to be, when we start way to the left, less than, that's negative infinity, and comma, go all the way up to negative 1. And since there's no equal sign, just less than, then we just have parentheses. So negative infinity, negative 1, open interval. And that's our answer. So this has been McGahee with Linear Inequalities. Hope you learned something on how to solve these guys, and we will take a look at some compound linear inequalities, how to solve those. So stay tuned.